will we end up writing?
3.
Yes, because it's a binomial squared and we know it has 3 terms. Very good. So give me the first term squared, give me the second term squared, and then we'll work on the middle term, which is absolutely perfect. If this method works for you, it's awesome. Good. Can anyone give us the first term squared?
Y6.
That's it. Very good. Can anyone give us the last term squared? Can anyone give us the last term squared?
1/16 t squared.
Excellent. So then here I have to have a 2. I have to have first term times the second term. Perform the calculations, tell me what to write, and then you can cross it out. Or not. You can leave it there. It doesn't bother me at all. If you want to delete it, you can delete it. If you want to keep it and cross it out, fine. If you want to keep it and not cross it out, it doesn't matter.
Half y cube.
Yes.
Cube t.
Yes. Y to the third t. Excellent. Very good. Any questions before we move on? Now, this is just a quick review of the numerical situation. How would you do this? Well, we have to square by the order of operations. You're going to see a problem like this in homework, in practice. So all I have to do here, this is not a special product. All I have to do is write 64 plus 9, which is 73, and it's done. Now, if you have 8 plus 3 squared, you're not going to use a special product because 8 plus 3 is 11. So first you will perform the operations like we always did, the operations in parentheses, and then in this case, I have to square and I get 121. Can anyone help us with 7 squared minus 6 squared? Yes, this one, if you want, you can use the special product. And how will I factor? But we haven't gotten to factoring. So you will have 7 minus 6 and 7 plus 6. But who will do this? Sometimes I do that when I simplify something. But there is no need. Indeed, 7 minus 6 times 7 plus 6 is 7 squared minus 6 squared. But there is no need to do that. Because 7 squared is 49, and 6 squared is 36, and when I subtract, I get 13. Will I get the same thing? Yes, of course. This is 1, and this is 13. 1 times 13 is still 13. But we don't use the special product on numerical situations. We use a special product on polynomials, not on numbers. Again, here with 7 minus 6, everything squared. I'm not going to use the special product, the first term squared minus 2 times the first times the second plus the second. No, 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 no. Because this is 7 minus 6 is 1, and 1 squared is 1. But you're going to see something like this in practice, so I just wanted you to be aware of it. Let's look at one more. X plus 1/3, everything squared. Now, what special product, if any, is applicable here? which special product is applicable here? You can say a binomial squared. That's how I would answer, a binomial squared. How many terms do I have to write?
Three.
Yes. So please give me the first term squared and the last term squared, and then we'll check the middle term.
X squared and 1/9.
That's it. And we know that the middle term has to be 2 from the formula, x, which is the first term, and 1/3, which is the second term. How do I write the middle term? And again, I hope I convinced you to use the special products and not FOIL. It's so much easier.
2/3 x.
Yes, that's it. That's absolutely it. Very good. Okay, any questions so far? Any questions? Okay, so let's look at a little bit more, if you want, involving, nothing difficult, a little bit more work type of problem. So I think I'm on page 4. Yes, I am on page 4. So what if I have x plus 2 everything to the third power? Yes, we have rules for this too, or special products, but there is no need. Let's see how we determine this. We only know x plus 2 squared, but I know what x plus 2 means. To the third means x plus 2 times x plus 2 squared. Copy the base and add the exponents. 2 plus 1 is 3. Because I don't know this special product, but I know this one. So I keep the x plus 2 alone in front. Now when I square a binomial, how many terms will you give me? Three terms. Perfect. Please square the first term, square the last term, and then we'll talk about the middle one. When we square the first term, we get
X squared.
very good. When we square the last term, we get
4.
excellent. And I know that the middle term has to be 2 from the formula times the first term times the second term. Perform the operations and give us the middle term, please.
4x.
Yes. Now, from here, I know how to multiply. I distribute x to 3 terms, and then I distribute 2 to 3 terms. We know how to multiply a binomial by a trinomial. So let's distribute x to these 3 terms. What do we get? Please.
X cubed 4x squared plus 4x.
Very good. Plus. Let's distribute now 2 to these 3 terms.
2x squared 8x 8.
Very good. In descending order now, where is our starting point?
X cubed
Indeed.
plus 6x squared
Indeed.
plus 12x.
Excellent. This is the expansion of this. X plus 2 to the third power is x cubed plus 6x squared plus 12x plus 8. Notice something very interesting. When the power is 2, how many terms do we get?
3.
One more than the power. When the power is 3, how many terms do we get?
4.
4. One more than the power. The power here was 3. We got 4 terms. When the power is 2, we get 3 terms. Always a binomial. So binomial to power n results in n plus first terms. If the power is 2, I have 3 terms. If the power is 3, I have 4 terms. If the power is 10, I have 11 terms, and so on and so forth. Okay, here's another one. 4x plus 3 times 4x minus 3 times 16x squared plus 9. Yes, we may be tempted to, let's distribute. No, 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 no. Let's think. Let's look at these two. Is this by any means a special product? If it is, let's use it. I'm not against foiling. I'm against going backwards in algebra. Is this a special product? 4x plus 3 times 4x minus 3?
Yes.
Yes. And obviously it's the difference of squares. Okay. So I'm waiting for you to tell me what to write. Because this is not a binomial squared. It's the product of two binomials that are identical, but the sign in the middle is different. One is positive and one is negative.
4x squared plus 9.
So it has to be the difference of squares, not plus.
Minus 9.
Yes. But let's square again 4x. Careful.
16x squared.
16x squared. Now, look here. What is this?
Another difference of squared.
Exactly. This time I don't need parentheses. And I'll tell you 16 times 16 is 256. But what about x squared times x squared? Or if you want 16x squared squared. I have x to
X to the 4th.
Indeed. Minus the second term squared, which is
81.
81. This is it. It would have taken you way longer to distribute. Special products are easy, condensed, easy to apply if you understand and you remember the pattern. Good. Any questions on this problem or these problems? Okay, here's another. I'm on page 5. Okay, so we have 4p, p minus 4, everything squared. Please do not make the mistake of attempting to distribute 4p anywhere, because by the order of operations, we have to raise this quantity to the second power first. You cannot distribute to 4p inside. You cannot do that. It would be incorrect. So we keep 4p outside. Which special product is this? And how many terms we have to write?
Three terms?
Yes. Please square the first one, square the last one, and then let's think about the middle term.
P squared 16.
And we know that the middle term has to have 2 from the formula. Times, not plus, times. P times 4.
8p.
8p. That's it. You can cross it out or leave it alone or whatever. Good. Okay. Here's the next problem. n plus 3 times n minus 3 and plus n plus 3 squared. N plus 3, n minus 3 plus n plus 3 squared. If this is a special product, we have to use it. If this is a special product, we have to use it. Please do not FOIL. Good. Is this a special product? If it is, tell me what it is.
N squared 9.
Minus 9. It's the difference of squares. Very good. Plus. What is this? And how many terms will you give?
3.
Yes. So
N
let's.
squared.
Yes.
6n.
Indeed.
9.
That's it. Combine like terms. 2n squared plus 6n. I think at least I'm convinced. I convinced one person to use the special product. I hope I convince more than one. But at least I convinced Rachel. And I think Janelle too. I hope I convinced. I convinced. Okay, good. I'm super happy. Okay. One more. Let's look at a word problem. And we have an area, a rectangular figure with a length of 3x minus 1 and the width of x, that has somewhere in the middle, somewhere it has this piece that is an x minus 2 by x minus 2. What is the question here? We're asked to determine the red area. So they are asking us to find this area. Can anyone give us an idea of how to proceed?
Would it be in parentheses 6x minus 2?
So first we have this big area, which is 3x minus 1 times x. And we have to subtract from it this area. What is the area of a square?
Length times width?
Yes, but it's because they are the same, it's x minus 2 everything squared. But it is length times width, I agree. But it's x minus
2?
It's I'm sorry?
8x minus 2?
I don't know. So here we have to distribute. We have 3x squared minus x minus. We reach the binomial squared. Put parentheses because we have to distribute the negative 1. Can anyone give us the terms that replace x minus 2 everything squared? How many terms will you give? How many terms will you give, please?
Three?
Yes, please give me those 3 terms.
X squared minus 4x minus 4?
The last term, the last term in the binomial squared, yes, it's always positive, yes. But now we have to distribute the negative sign. That's why I still kept it in parentheses so I don't forget. So from here we have 3x squared minus x, but minus x squared plus 4x and minus 4. So, can anyone help simplifying, presenting the descending order of this polynomial. I'm entering attendance. That's what you're hearing this moment. After each class, I have to enter attendance. Good. So we have 3x squared minus x squared, which is 2x squared. We have negative x plus 4x, which is positive 3x, and minus 4. What does this represent? It's the polynomial that represents the shaded area in red. That's the polynomial, 2x squared plus 3x minus 4. Any questions? Any questions? Okay. We touched up on every type of problem. Now we are ready to move on to 5.6. Unless you say, no, I need to see more examples. Okay, the last section of this module 5 is called scientific notation. You've seen this before. What is this? Why is this so important? Because very, very small numbers and very big numbers are presented in scientific notation. Normally, will I present 2.39? Let me put 142.39. Is it really important to put this in scientific notation? No, it's not. But what about this number? And the calculator uses it. The calculator uses the scientific notation. What about this number? We want to use the scientific notation on such a small number. Also, on this number. We don't want to write this. We want to use the scientific notation on tiny numbers or big numbers. On 142.39 is not such an, the calculator will not present this in a scientific notation. So it's not a big deal. But for these numbers, yes. And we have to be able to read what the calculator is telling us. Okay, so first of all, what is the definition of the scientific notation? How does it look like? The scientific notation looks like this. One digit. And this digit can be from anything from 1 through 9, not 0. Then the decimal point. Then whatever. And then multiplied by a power of 10. Careful, Pearson puts an x. I don't like to put an x. This is not the variable x. But they put, instead of the raised dot, they represent multiplication with a tiny x. So don't get confused. It's not x, it's multiplication. But now there must be a power here. I'm going to use a different symbol than this one. So this is a digit 1 through 9, and this can be anything. But this number can be positive or negative. When will it be positive? It will be positive for large numbers. And it will be negative for small numbers. So what am I saying? When we get to represent this tiny number, it will be la 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 times 10 to a negative power. When we get to represent this number in scientific notation, will be a first digit, ta 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 ta, times 10 to a positive number because it's a large number. Again, when I represent a small number in scientific notation, the power of 10 will be negative. When I represent a large number in scientific notation, the power of 10 will be positive. Okay. Now, let me tell you how the calculator, and we'll look at the calculator in a second, and we're going to use the scientific notation on numbers in a minute. But what I would like you to know is that the calculator presents something like this. 2.3, for example. Then it uses a uppercase E, and then let's say -10. What does this mean? Is 2 is the first digit, the period. 3 is this piece, times 10 to power -10. So this is the same with 2.3 times 10 to -10. But this is how the calculator is presenting it.
I guess it's already expecting everybody to know the times 10, so it only gives the exponential.
Yes. Yes. That's one of the reasons we discuss scientific notation. What about 1.99E3? This means 1.99 times 10 to the third power. This is a very small number. This is not small. In other words, what will the number be? 10 to the third power moves the decimal digit 3 units to the right. So this is 1.990. What will this be? This 10 to -10 moves the decimal point to the left 10 units. What will I get here? And I'm going to move on to the next page, because I don't want to put it in there. So what are we going to get there? 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I move the decimal point 10 spots to the left. Okay, so let's start with the numbers that I just invented here, and then we'll look at examples. Let me see the time here. Oh, it's 27. Okay.